Started my first startup in '97. The world told me I was insane.
Our goal is creating future economies that are more regenerative and sustainable.
Something didn't match up. Why hasn't this become the next big thing? And that's where we invested.
The whole purpose of achieving anything in life is measurement.
How's it going?
Fantastic. How's it going?
I'm doing great.
I hope I hope your day is going well.
For sure.
I wanted to come over and kick things off.
Okay, great.
For everyone who's attending, I first want to fully disclose that we are big fans of Lee Lance and his company EcoBot. We're actually an investor in the company. So with that full disclosure, wanted to go ahead and introduce the panel or the topic for discussion today. Title of Lee's discussion is pre-construction related environmental policies and regulations. In the discussion, mainly we're covering policies and regulations and how they're ebbing and flowing with the political tide. If anyone listening in caught the infrastructure bill discussion earlier today, I think that's a kind of a perfect example of how important some of those political shifts are. And again, we'll be kind of, I think, segueing some of that conversation with Lee today. The property built workflow focused digitization of environmental permitting processes, which is a lot of what EcoBot manages. This has become a really, we think, an important part of the pre-construction process as a whole, gaining efficiencies, gaining better clarity into data, as you think about, as you think about bringing efficiency to really important environmental work, and also leveraging that data to improve how we think about pursuing properties, land, et cetera, within the related field and site selection. We've been pretty excited about kind of where Lee is. He's headed with his vision with EcoBot. So with that, Lee, I will pass it off to you and let you expand on all this and take it from here.
Great. Thanks, Nick. I appreciate it. And hey, everybody. I'm Lee Lance with EcoBot, and I've got a few thoughts to walk you through. I've got some slides to show, so hopefully that'll show up without a hitch here, Nick. And then it looks like there is a Q&A tab on the sidebar here. So as we're going, ask questions if I'm able to. I like things to be as conversational as possible. I'll try to field those as they come up, or we'll have a little chat at the end. But I think one of the things that I'm really interested in as a participant also in Shadow Summit is the conversations around all of these different topics that are being presented. I'm in it every day. I live this with my team, so we certainly have some thoughts to share, but really want to hear from you too on what you're encountering, what your pain points are, how you're going about solving some of these issues. So we'll jump right in and go from there. So let's see here. Looks like this one. Nick, can you see that screen?
I can. Yep.
It's not my presenter slides. It's the main slide.
It's the main slide. You got
Great.
it.
My first time with this tool. So great. So again, swifter pre-construction environmental permitting, and I think it's just as Nick outlined here. The policies and regulations are always changing with the political tide. Every time a new administration comes in, things shift, and it creates a lot of chaos. It further delays an already complicated process. And I think one of the interesting things is it's not the reporting requirements that change. It's the response to the reports, and sometimes the complexity of the reports that are required. And one of the ways, the political tide is something that's completely out of everybody's control. And so what I want to talk about here is present some ideas on what we can do, what you can do at your organization to try to normalize some of the ebb and flow, and ultimately allow for faster project starts and projects that are done right the first time. So I think the first thing to look at is, who cares, right? I mean, the Bugs and Bunnies folks are out running around in the field with pen and paper, just making the project start even later. Here's why this matters. This is why this is something that can be addressed. We can do something to, again, normalize some of the political ebb and flow, and we can address the challenges that are presented by these problems. Delayed project starts that contribute to project backlogs, and regulatory uncertainty, which create risk for organizations and for their clients, for landowners. And it's because of this environmental policy ping pong back and forth every administration, and how things are defined, and how regulations, what regulations are required to be responded to. And just to walk you through an example of this, WOTUS. I'm sure you've all heard of WOTUS. It's Waters of the United States, if you have not. There's a little graphic here up on the screen. Hopefully you can see it here, where things stood. And you don't have to read all of the little details of the words, but basically this is a diagram of everything from snow melt to isolated wetlands to streams and creeks and rivers and bays. And this is the definition by the EPA of what is considered jurisdictional, or what the federal government has jurisdiction over as it relates to water. And when the Obama administration was in control of the EPA, the Clean Water Rule changed a lot of the definitions. And I think the important thing to point out here, you can see in the previous graphic, there's a bunch of gray items, and some of those items are now colored in this graphic. So you can just kind of at a glance see things changed a lot. And then in the last administration, there's a lot of gray. And the Navigable Waters Protection Rule was brought about and changed things even further. And so this is just around one tiny issue related to the definition of what is considered jurisdictional for waters of the United States. Well, you're probably aware of what happened earlier this month in Arizona. I guess it was a federal district court vacated the Navigable Waters Protection Rule and returned all of the details, all of the requirements back to how things were defined in 2008, so pre-2015. And this is, one of the things that happened when in January with the Biden administration, there were assumptions that we would be working back toward the Obama EPA definitions from 2015, and so some projects were underway. Working according to the Navigable Waters Protection Rule, they changed gears, started working toward the 2015 definition when the Navigable Waters Protection Rule was vacated by the federal court in Arizona. It didn't revert back to 2015. It reverted back to pre-2015. So some of these larger projects, especially infrastructure and energy-related projects, they've been reworked 3 times now already, or about to be worked a third time, just in a short span of a year. On top of the political changes, there's a lot of complexities around what has to be reported and what this means. One of the things that EcoBot focuses on is wetland delineations, or the identification of where a wetland is or isn't, for the purposes of determining whether or not you have to obtain some kind of a permit in order to proceed with construction. Well, things aren't always what they seem. Wetlands don't always look like swamps. And what you see in this mess here on this screen is just an example of what the natural resources teams at civil engineering firms, or subcontracted by the engineering firms, are out there doing. They're having to identify scientific names of plants. They're having to identify different things in different levels and different depths of soil. They're looking across this entire property to determine if an area is a wetland or an upland. Most of the time, this is being done on paper. It's a mess. If it rains, you get mosquitoes, whatever, mud. These teams are going in the field. They're doing this work. It's an arduous task already to do the work, but then the work is duplicated back in the office as they go through and QA/QC their math, their Latin spellings, their identification of indicator statuses of vegetation. A lot of inside baseball, basically. It's complicated, and it's done twice. And this is all to determine if this is a wetland or not, so that this construction project can proceed. This is what's going on if you're not in the details of why these project starts are slow. So there's a need to digitize field data. The data is being captured, but it's being captured by pen. It's maybe being entered into an Excel spreadsheet or put into a PDF, but nothing else really happens beyond this initial use of this data for the purposes of making this determination in order to be able to determine how to do the planning stage of a project and how to proceed with construction. So we've already mentioned faster project starts are possible by leveraging technology, but there are a bunch of additional benefits that go way beyond faster project starts. There's the ability to capture sub-meter accurate location information with now newly very affordable GNSS GPS devices. Not very long ago, the devices were cost preventative to send out with every field team, and metal wires with flags on them were being put in the ground. They weren't necessarily carrying any technology. A survey crew had to go out later and shoot all of these points, get that back to the GIS team, who had to turn it into a map, and then get approval. This is what the natural resources team really saw in the field. That entire process has been short-circuited by these newer, more affordable Bluetooth-enabled devices that let these teams go out and capture their data in a sub-meter accurate, geospatially correct manner the first time. I think the big thing that there's the biggest thing that there's an opportunity to benefit from immediately is that instead of capturing data in the field and then post-processing it later in the office, which is where the knowledge is built, and then sometimes you find, oh, well, this isn't what I expected. And now, because I've done these calculations back in the office, I need to go back out to the site, delay the project even further, and do some more investigation in order to build this knowledge. But there's an opportunity by digitizing this data to build this knowledge, actionable knowledge in real time in the field, and correct and adjust as needed. There's, as you can imagine, or as you may have experienced, there's a lot of error. There's the potential for error. So even if things are correct, there's this overhang of potential liability. There's the opportunity to eliminate this lengthy QA process, sometimes that takes as long in the office as it does in the field. There's I mentioned earlier the GNSS devices. We can go straight from the field by capturing things digitally directly into GIS-ready shapefiles and eliminating some steps. There's an opportunity to use this raw data in other applications in the planning process. And one example of that is the ability of capturing field data to contribute to a robust digital twin of built assets in the environment. We'll talk a little bit more about where things are headed there and what we're hearing from our customers. So how do we do this? What needs to happen in order to be able to move this from a traditional pen and paper process into something where we're not just moving faster, helping projects get started faster, but being able to leverage the value of this boots on the ground data that's being captured ahead of really every construction project in the country? Well, there are a bunch of different options. And we see companies going about this in different ways. And I think the three key categories to consider for digitizing this field data collection is an off-the-shelf mix, working with pivot tables and Excel and maybe an Access database, and possibly generating automatically some PDF forms as a part of that. It's one of those things that it works great for some people, or it works for a little while, and then a lot of problems can happen if you move things to the wrong location, or if you try to throw something new at it. It's complicated to set up. It's unreliable, but it does, in some cases, get the job done. It at least can begin to move you from paper into some sort of more easily manipulated digital format. There are also a lot of options out there for low code or no code field data collection deployment. A great example, we're an Esri partner, and one of their products that is great for a lot of collection of data in the field is Survey 123, where it gives you the ability to build your own survey, roll it out into an app, take it out in the field, and capture that data and bring it back into the office. Again, it moves teams further in the right direction, away from paper, more advanced than an off-the-shelf mix, often relies heavily on either very tech-savvy individuals in a natural resources department, or a lot of work from an IT or GIS team in order to not just build it and deploy it, but keep it maintained. And then the third option is industry-specific workflow-based platforms, like EcoBot. And what we've done, and I think what's different about this approach, and we hear from our customers that they're able to accelerate through their backlog work twice as fast. They're able to accomplish twice the volume of work with the same resources on their team. And they weren't, these are even teams that were using things like Survey 123 or an off-the-shelf mix, or a paper solution for collecting data. And the biggest difference, the reason we're able to make the biggest impact, is because it is a workflow-based platform. It's more than just collecting data in the field and producing documents. It's providing a lot of lookup tools and on-the-fly calculations, and presenting things in the way that regulators need to receive them. When the first Apple computer came out and the marketing materials came out, they had the headline, "Simplicity is the ultimate sophistication." And that's the approach that is possible when you're building a workflow-based platform, because digital shouldn't just be a transference of inefficiency from cobbled together Excel spreadsheets and pivot tables or paper processes. It should be an abstraction of the real process. Otherwise, what teams find is that they're in a position where they haven't created efficiency, they've just transferred the inefficiency from one process to another. And it's only through a deep understanding of an offline workflow that you can really, truly impact efficiency. We do this, and any tools that are workflow based often follow this. They call it the lean startup model of a build, measure, learn feedback loop. So we are constantly engaged with our customers. We build a little bit, we test it, we get feedback, we make modifications, we release it again. The software as a service model enables companies like EcoBot to be able to work in that way, instead of going away for 2 years and building software that you only use 20% of. We're able to make sure that every aspect of the platform that's being deployed is perfectly in line with what is needed in the field in order to achieve this efficiency. In addition to that, the ability to monitor and modify as needed as these policy changes arise, and when things like new wetland plant lists are released, or new regulations around streams, or threatened and endangered species lists. Those are the kinds of things that we wake up every day and are able to go out and deploy and put into the app. And ultimately, I think it comes down to that great software is invisible. It's not about the app. It's not about the user experience. It's about what the user is trying to accomplish. And a good user experience, we believe, is when the people using the software, they're able to do their job, and the software is not even there. So let's take a look at a couple of case studies. Here's a project from Burns McDonnell, working on a 1,400 acre project, an energy related project. They were able to really accelerate this project, and it was they were given a short timeline. There were some regulations that were changing that they were trying to get ahead of, and they were able to, with just a 2-person team, complete the work that they needed to, with 33 sampling points, 32 mapped wetlands in only 3 days across the site. And the entire process, because they were then presented with this information, not with a pen and paper and a write in the rain notebook, because it was digital, they were able to flow that information into their reports and the regulatory submittals. They were able to get the entire process done in less than a month. Another project here, a 3,000 acre solar farm. This particular customer, ESC Partners, they were able to realize a 30% increase in their profit margin on this project. This was larger. It was an agriculture conversion to solar farm. They were completing 31 points a day, which is twice their usual productivity. Overall, they were able to do this project twice as fast than they had anticipated, and completed 250 sampling points, all of these dots on this map, upland and lowland, and mapping wetland polygons in order to obtain these permits to be able to accelerate this project start. They were able to complete this in only 14 days. So where do we go from here? What's next for the industry? And there's a quote here from Keith Bentley. Technology is past the good idea stage. It's really at the how to make it work best and how to deploy it stage, and that's what we're seeing with our customers. We're seeing that the industry is ready to begin to digitize this stuff that needs to be done ahead of construction in order to fulfill these regulatory requirements. But we can go a lot further. We can go a lot further with this data that now we've accelerated the permitting process. We've accelerated the project starts. So how can we work better? And it's the real-time collaboration between the field and office, better, more data-informed decision-making. There are, as you know, silos in the entire process that are broken up by different types of software, different types of data needs. Being able to get information across those silos and improve collaboration. This workflow-based efficiency tool doesn't just help speed these starts, it drives the creation of data. We can leverage this data into digital twins of assets, not just in the design stage, but also in the building and management stage. Just as an example, if you were building a hospital, and you were able to have a digital twin of this asset, and you had real data that had been collected about the natural resources and permitting requirements on this piece of property, we can help the engineers whose job it is to solve problems. We can equip them with better information to better solve those problems during the design phase. We can have a better understanding of what the natural resources assets and permits are during the building phase, and make sure that the building phase is held accountable to the permitting that was met before the design stage. And then in the management stage, if we've got a digital twin and super easy to use data collection tools where we can go out and update information that was collected ahead of design, ahead of construction, we can update and see how things are flexing, how things are changing. Are streams moving as they're wont to do? Is a wetland enlarging? Is it shrinking? How is the land around the asset, this hospital that you've built, being impacted by the impacts of climate change? And in this in this digital twin, we can maybe pull up and see, hey, there was a wetland to the west. So maybe as we're looking to expand a new wing, maybe that needs to happen to the east, and we can get to those conclusions in a faster way. We can move through those project backlogs. We can make better decisions. And so I'd like to. This is the last slide, and I'd like to hear what your organization is focused on. What are your needs? What do you see as opportunities to create efficiencies to help projects start faster, and then leverage that data into the processes that you're using? Looks like there's a few questions that have come in here. So I will. And if you haven't chimed in with any and have any, certainly contribute here. A large developer always waiting on our environmental consultants. They don't seem to understand deadlines. That is definitely something that we hear frequently. You can do progress tracking of their work. In fact, the very first case study that we worked on, we had the opportunity for as the data was coming in, the planners and engineers were able to look over the shoulder of the project manager and see over the course of these 3 or 4 weeks, while the data was being collected, where the sensitive areas were on the property. There was a large inland port project that was being worked on at the confluence of the Ohio-Mississippi River. So there was already an understanding that they were going to have to be dealing with a lot of wetland and stream and threatened and endangered species. I think there were issues with mussels and bats, and it was you name it, it was present. And so they were very anxious to begin doing some of their preliminary planning, and they were expecting to have to wait the month that it took to do the environmental assessment, and then weeks after that, not really knowing where the project was or where it stood. Is it in somebody's notebook? Has it been digitized? Do we have a permit? What's going on? They were able to have that visibility in near real time. Again, as an offline process, we weren't feeding that information to the engineers yet, but they were able to access that information and leverage it to accelerate their project. Yeah, so a couple of questions about existing GIS mapping tools from Sarah, and yes, so Fish and Wildlife, or the FEMA Interactive Flood Map tool. EPA has a map of wetlands every 4 or 5 years. They do a national wetland condition assessment. U.S. Fish and Wildlife has the National Wetland Inventory List. If you've worked with these lists, you know that they're often wrong. It will say there's a wetland here, and here's the identification, the National Wetland Identification ID, and you get to the site and there's nothing there. Or you're working on a site and it says there's not a wetland anywhere within 20 miles and the entire site is wet. So a lot of these mapping tools are fantastic resources ahead of boots on the ground to help decide how long do we need to plan to do this natural resources assessment ahead of this project. How can we identify where there's a likelihood of some areas that we want to make sure that we pay really close attention to. But those tools don't answer what needs to it doesn't answer what needs to be answered in terms of permitting before you can begin construction and start moving that dirt. So those are great tools. Those are things, those maps are integrated into EcoBot, for example, so that you can see that as you're beginning to do some of that planning. There's a question here, where does the workflow begin and end? Which part? I think that there's the workflow of individuals, there's the workflow of departments, there's the workflow of the entire construction process. And I think the opportunity is in what our approach is we've identified and improved initially a super narrow part of this workflow. Specifically when the person goes out in the field to do the work to identify whether there's a wetland present, map that wetland, look for other sensitive areas, and then proceed to provide that information to the GIS teams, get data into the hands of the planners and engineers, and produce the required documents for permitting. That's where it currently begins and ends. But the opportunity, as all of this and in adjacent tools and partnerships that we're developing way earlier in the land acquisition phase, all the way through more detailed phase ones, or off to mitigation banking, both in the purchase and then the acquiring of land and the maintaining and monitoring of mitigated wetlands, out into the building process, getting the data into the hands of engineers, into the hands of construction teams, and into the hands of planners that are continuing to maintain and manage an asset through its life cycle. I mean, really, the opportunity for workflow is the entire scope of the construction process. A lot of people are talking about this question. There's a lot of people talking about digital twins at this conference. Seems like a buzzword. It is a buzzword, and I'll tell you, it's interesting. The digital twin is not just a fancy way to say there's a software screen version of something that exists in real life. A digital twin, in order for it to truly be a digital twin, think of a simulator and then think of multiple simultaneous simulators. Because it's usually there's not a one-to-one relationship between two objects in real life. You have multiple things that interact together to create something new. And a real digital twin is a true, detailed, robust digital version of what you see in real life. So when you're looking at a digital twin of an asset, I use the example of this hospital, this hypothetical hospital that was being built. If you have a full digital version of all of the systems and doors and fire alarms and plumbing and electrical and all of the things that you need to deal with in planning the construction and then constructing and maintaining this asset, the other piece that is incredibly important to building a real digital twin is looking at what is the natural environment that this asset lives in. And so where we fit into a digital twin, EcoBot is able to collect and provide actual natural resources data before, during, and after construction into a digital twin to ensure that there's an accurate natural resources component to the full digital twin model of where the asset exists in real life. Does that answer your question? I don't know if anybody can reply on. This is not a super interactive chat, but is EcoBot building a digital twin? No, because that would just be one narrow piece focus. That'd be a model or a simulator or software version of reality. What we're doing is we're collecting information that is essential to creating a robust digital twin. So there's another question. Are there any challenges with environmental or historic preservation that may not be publicly available or residential data? Yeah, there's a firewall between our customers' data that's private to them and ultimately private to their client. Whether they specifically identify that to us as being sensitive information or not, we treat all of it as if it were sensitive information. So none of it is publicly available. When information is sent to the federal government, in the case of wetlands, to the Army Corps of Engineers, and the federal government makes a decision on jurisdictional determination in related permitting, that information is now available to the public. Any of that information can be obtained through a FOIA request. And so we have the ability to leverage that geospatially accurate information that has become public. I would say we're at liberty to do that, but we still yield to the privacy of our customers with the geospatial accuracy of that information. So mitigation related, there's the ability to look at the data that is coming out to build a digital twin of an asset, and the people that own that asset, the developers, the owners, the engineers, the construction teams, they can see and access all of that information within their project. There's the opportunity to see what else is happening. Like, for example, something that's valuable to mitigation banking is the ability to see what specific species exist on a project that's being disturbed and how that impacts how many mitigation credits are required for you to obtain in a mitigation bank. So as you're beginning to do some of the research around that, we have the ability to surface some of that aggregate de-identified data from the data that is inside of EcoBot that you can associate with a specific parcel of land. It's not geospatially represented. It would be like in a particular river basin or within a floodplain, being able to see collectively data across that, where you could leverage that into some of your planning for something like mitigation banking, or maybe some preliminary mapping of preliminary creation of something like a digital twin. Any other questions? Can I explain how mitigation banking works? I can explain it at a very, very high level. Basically, if you have they're called an EPA ecoregion or a river basin. You can imagine at a very basic level, if there's a valley and there's a river in the middle, all of this is part of the same region. And if on one side you're disturbing an acre of land and there's a wetland that's present there, and you can't plan your project around it, it's too large, you have to get a permit, mitigation banking is required, you've got to buy mitigation credits at a mitigation bank that's in that same river basin, essentially, in order to offset the impact. You can't just like be working on a project in Texas and buy a mitigation bank in North Carolina, because it doesn't work that way. It's nice, great, sure, you just preserve some land, but it doesn't have that same impact around waterways. So one of the things that's looked at when you're identifying, I've disturbed an acre, can I just buy an acre? Maybe. One of the things that has to happen is a qualitative assessment of what's being disturbed and what's available in the bank. And the closer that you have alignment between those two, the lower the number of credits are that are required. So if you had a 90% overlap, say, of tree species that are wetland indicated tree species in the area you're disturbing, maybe you can buy 1 mitigation banking credit or 1 acre, however it's defined. If maybe you have a whole bunch of species and the mitigation bank that's available in that area only has 50%, maybe you've got to buy 2 credits. Those are defined. It's different across from region to region, from state to state, and different requirements. But essentially, that's how mitigation banking works at a super, super high level. Do we have a marketplace for mitigation banking in the product? We have a marketplace for mitigation banking in the roadmap of the product, but not in the product right now. We're able to provide that essential data that you need. You create a project. We give you the data that you need in order to identify what those species are that are wetland indicated on the project, so that you can flow that information into identifying the mitigation bank that's in your area, and be able to proceed with that outside of our platform. But again, the where does the workflow start and stop? there's not really an end to this in what we're building and what we have the ability to create and how we can leverage this data, and is really largely driven by our 90 customers and where their biggest pain points are. We've solved a lot of problems for their teams already, alleviating some of this project backlog. And so one of the things we do is we have a customer advisory board. We meet quarterly, and we go deep and we talk about roadmap and some of these things and figuring out where the greatest needs are so that we can focus our development team's efforts on that. Good question. Great. Well, thanks for the questions. I appreciate y'all sticking around and chatting. Hey, KP, you're welcome. Thanks for having me. Appreciate the opportunity. See y'all later. Have a good rest of Shadow Summit.